All right, here we are with section 9.2. All right, we're continuing to deal with square roots. So we have the product property, which says the square root of a product equals the product of the square roots of the factors. So I have the square root of a times b. That's the same thing as the square root of a times the square root of b. Or if I had the square root of 4 times 100, that's the same thing as the square root of 4 times the square root of 100. We have the quotient property, which is the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. So if I have the square root of a fraction a over b, then that's going to end up breaking apart to be the square root of a over the square root of b, as long as a and b are greater than or equal to 0, because we can't take a square root of a negative number. All right, so same thing, like if that's the square root of 9 over 25, that would become the square root of 9 divided by the square root of 25, or the square root of 9 over the square root of 25. And then tells us that an expression with radicals is in simplest form if the following things are true. Right? No perfect square factors other than 1 are in the radicand. So if I have something like the square root of 8, it actually has a perfect square root in there, because 8 is the same thing as 4 times 2. So I can take the square root of 4, and that'll give me 2, which can come to the outside. 2 does not have a square root, so it's going to stay underneath there. So 2 comes out, square root of 2 stays under there. No fractions are in the radicand. So the square root of 5 over 16, we can't leave that fraction in the square root or in the radical, because then that's not in simplest form. So we break that apart using that quotient property. Becomes the square root of 5 over the square root of 16. 5 doesn't have a square root, so it stays the square root of 5, but 16 has a square root, which makes it 4. And then no radicals appear in the denominator of a fraction, right? So we cannot end up with 1 over the square root of 4. We've got to do something with that square root, because it's inappropriate for a square root or a radical to be in the denominator. So we go ahead and apply that square root, and that becomes 2. Square root of 4 is 2, so 1 over 2 would be the simplified form of that radical. So these, we want to simplify the expressions. So the square root of 48. So one way we can do this is we can make a factor tree, right? Because if we look at 48, think of the numbers that go into 48. Or if you can't think of numbers right off, you can always, if it's an even number, use 2. Right? And 48 divided by 2 would be 24. Then we can break down 24. It's even again, so we could use 2 again. And 24 divided by 2 is 12. Once again, another even number. So we could do 2 again. 12 divided by 2 is 6. And once again, we have another even number, 6. So we can use 2 again. So that's a prime factor tree, right? All these are prime numbers left over. 2, 2, 2, and 3. Now, when we do this, we're trying to find things that can come out of the radical, or to simplify what's underneath the radical. So since it's a square root, we need pairs of things. So I have a pair of 2's right there. I have another pair of 2's right here. And this 3 right here is all by itself. So basically anything that has a pair comes out. Anything that's all by itself stays home. Kind of like if you're going to go out on a date, you need a date to go out with, right? If you don't have a date, then you stay home. So I got 2 sets of 2. So that gives me 2 2's that can come out of the radical. And 3 stays behind. Now, outside the radical, we can go ahead and multiply the 2's. 2 times 2. And we end up with 4 square roots of 3 as our simplified expression. Next one, simplify the expression, the square root of 50. We can go through the same factor tree process. So 50, you could do 2 and 25. Now 25 is not even, so we can't use a 2, but 25 is the same thing as 5 times 5. And now those are prime numbers. 2 is a prime number. So 5s, there's a pair of 5s. 2 is all by itself. So this becomes 5 on the outside. And 2 stays on the inside. 5 squared is 2. Simplify the next expressions. So we have the square root of 7/16. So we can go ahead and break that apart. Become the square root of 7 over the square root of 16. 7's a prime number. We can't really do anything with that. So it's going to stay the square root of 7. But 16, you should know that 4 times 4 equals 16. So 16 has a square root, which is 4. So the square root of 7 over 4 is going to be our simplest form there. B, the square root of 18 over 3. So we're sitting at the square root of 18 over 3. So we want to simplify that if we can. So look at 18 over here. It's 2 times 9. And if you didn't know, 9 has a perfect square root, which is 3. So 3 has a pair. 2 is all by itself. So 3 comes out. Square root of 2 underneath there, and then the 3 is still on the bottom of that fraction. Now if we look at this, those two 3's are the same, so they can cancel each other out since they're on top of each other in a fraction. And we simplify all the way down to just the square root of 2 for that answer. All right, so then the next one, square root of 80/45. Be the square root of 80 over the square root of 45. And those are pretty big numbers, so there's a likelihood that we could break those down and simplify those radicals a little bit. So we look at 80. That'd be 2 and 40. And 40 is even, so we could do 2 and 20, which is even, which is 2 and 10. 10's even again, so that's 2 and 5. So I've got 1 pair of 2's, 2 pair of 2's, 5's all by itself. So that's 2 times 2 going on the outside. So 4 square roots of 5 for the top. Then we're going to break down this 45. Break it down that it's not even. 3 will go into it though, times 15. And 15 is 3 times 5. So we got a pair of 3's and a 5 there. So 3 comes out, 5 stays home. So 3 square roots of 5. Now when we look at that fraction, we got 4 square roots of 5 over 3 square roots of 5. Square roots of 5 are the same, so they can cancel each other out. And we simplify all the way down to 4/3. So that's the basics of section 9.2.